Hello everyone, my name is Hani Hazwani binti Perlis, matrix number 73480. For the summary, the objective of this assignment is to determine the relationship of Reynolds number and geometry effects to the flow past immersed body. Drag force is the force which resists the motions of body with fluid. It is also identified as the drag coefficient. Drag coefficient of geometry depends on Reynolds number to identify type of flow, laminar or turbulence. Most geometries have a constant drag coefficient at high Reynolds number, while at low Reynolds number, the drag coefficient is not majorly affected by the shape of the body. The next objective is to study the relationship between Navier-Stokes equations and CFD in engineering problem. Computational fluid dynamics (CFD) is the field of fluid mechanics which applied basic Navier-Stokes equations and algorithms to solve problems related with flow of fluid. In other words, CFD uses numerical methods such as Navier-Stokes and allied equation to solve the fundamental nonlinear differential equation that describe fluid flow.
Assalamualaikum, my name is Nohani Farahin and I'm going to explain on the introduction and phenomenon description. The flow that passes the immersed body is considered as drag and lift. Its behavior is characterized by the drag coefficient, which depends on Reynolds number. The number determines whether the flow is in laminar or turbulent. The problems of external flow is easier to be solved using computational fluid dynamics because it serves a numerical experiment by solving the governing equations using numerical method. As for the description of phenomenon, in 2D flow, there has drag, which is the flowing fluid force in the flow direction, and lift, which is the normal to the direction. As for 3D flow, there is another force that the body tends to move in the direction.
Hi, my name is Nurfelian, and for this part, I will explain the governing fluid mechanics principle. There are three main principles governing fluid flow in which the continuity equations are used. This includes conservation of mass, the conservation of momentum, and energy equation. The governing laws of fluid motion can be derived using a control volume approach, whereby we investigate what is going in and out from the control volume. For conservation of mass, mass is conserved within a control volume for constant density fluids. Thus, the total mass entering the control volume must equal the total mass exiting the control volume plus the mass accumulating within the control volume. Meanwhile, for conservation of momentum, it relates to Newton's second law, which states that the time rate of change of momentum of a system of particles is equal to the sum of external forces acting on that body. Furthermore, the energy equation of Navier-Stokes system follows the energy conservation law, which equates the total energy of a system to the sum of work and heat added to the system. Another parameter that is important to look at is the Reynolds number, which is the ratio of scaling of the inertia of the flow to the viscous forces in the flow that will determine the behavior of the fluid.
As we all know, the shape of airplane is airfoil shape. So as the result, the lift force produced along the wing, which has the shape of an aerofoil, causes the aircraft to roll. The airflow above and below the airfoil is what causes the pressure difference. Without this airfoil shape, the lift needed to raise the entire aircraft would be insufficient. According to Channel and Kimball, a transient air's Reynolds number of range from 1000 to 2000. If the Reynolds number is greater than 90, vortices will emerge. As the result, the vortices as well as airflow in the crowded airport will always exist. A shading of whirling and circular airflow is produced by the airflow on the wing tip. Voltage drag or induced drag are two terms for this. The oncoming planes behind the incident plane that forms a verticized are at risk because the airflow beyond the plane may unintentionally induce the trailing plane to roll, which could have disastrous result.
Hi, my name is Kelvin Shelby Anabalang. So for this part, I will explain about the remedial action, which is the wingtip vortices are an unavoidable side effect of producing lift with an airfoil of infinite length. The wing is designed first to have relatively high pressure underneath the wing and lower pressure above it. Second, the air passing over the top of the airfoil is directed downward as it lifts the wings. Reducing the pressure differential between air above and below the wing will reduce lift because it is the pressure differential producing lift. By the same token, reducing the downwash of the back of the wing will reduce lift because the force creating the downwash is also lifting the wing. Therefore, conventional wings will produce wingtip vortices. By reducing the pressure differential at the wingtip, this is the major way swept, delta and double delta wing platform reducing tip vortices. Very simply, most modern wing on high speed or high performance jets have a smaller chord length and thinner cross section at the wingtip than the wing root. So that's all from me. Thank you.
In conclusion, the study of fluid behavior has a wide range of application and is very significant in daily life, especially in engineering field. Computational fluid dynamics (CFD) has been used almost in every industry, such as the applications in aerospace and constructional industry where fluid mechanisms are to be solved. The parameters involved in calculating drag forces, Navier-Stokes equation, Reynolds number, and others can be controlled to ensure safer and to improve fluid flow effectiveness for various engineering applications by understanding fluid mechanism.